Dear students, let's discuss about combined transformations, reflection followed by reflection. So here I am going to talk about such two lines of reflections which are parallel to each other. It means if there are two lines of reflections are given and it is asked what is the single transformation, that time we can see the single transformation is equivalent to the translations. So this is a theory. Now through one particular problem, let's discuss and explore this rule. So here is one particular problem. A triangle with three vertices A, B, C are reflected successively in the lines y equals to 1 and y equals to 4. So here reflected successively means at first we do reflection on y equals to 1 and second we will do reflection on y equals to 4. So I'll show this process manually. Look at this here. At first here this table represents the coordinates of images of triangle ABC when we do reflection on y equals to 1. I will try to give you reference. What is the formula for y equals to k? Our reference formula is y equals to k and it is x comma 2k minus 1. In this particular case here k means constant, and in case of y equals to 1, the value of k is 1. That's why I need to modify this formula. So I input the value of k equals to 1. So 2 into 1, so it will be 2 minus y. Sorry. So what I discussed here till now, so I have prepared the formula to find a dash, b dash and c dash when we do reflection on y equals to 1. Now it is very simple thing. By keeping the value of x and y from A, similarly x and y from B and x and y from C, in this formula x comma 2 minus y you will get a dash, b dash and c dash. This is your first image. But in this question it is the problem of combined transformation where reflection followed by reflection. Now there is second reflection also remaining, that is y equals to 4. Now let's discuss what are the images under this reflection on y equals to 4. So look at here in second column x comma y, reflection on y equals to 4 means again we have to take the reference from y equals to k. Our formula when it is reflection on y equals to k is x comma 2k minus y. In this case constant k equals to 4, that's why 2 into 4 equals to 8. So in this way I derived the formula. Now this is a continuous reflection, means from A you will get a dash and from a dash you will get a double dash. That's why you are finding the image of a dash, b dash and c dash, not a, b and c. So a dash, b dash and c dash, the value of x and y turn by turn will keep in this formula to get a double dash, b double dash and c double dash. So it is a normal process in this question. When we have to do the reflection successively in the line y equals to 1 and y equals to 4, and this is the complete process, and from this process we will get final image as a double dash, b double dash and c double dash. But if the question is asked, instead of these two successive reflection, what is the single transformation equivalent to this? It means instead of finding a dash from A and a double dash from A, is there some shortcut rule to find a double dash directly from A? That is called single transformations. So for that here, one method is, here I have listed on the bottom of this slide. Look at here. A is 1 comma 2, a double dash is 1 comma 8. Similarly B, b double dash, C and c double dash. You can see these coordinates very closely, and if you are really concentrating, then of course you will see here a kind of pattern. What the pattern here? When you are observing the coordinates of ABC and a double dash, b double dash, c double dash, there is no changes in x coordinate, but there is changes in y coordinate. So y coordinate, what kind of changes? Is it they are changing randomly or some common thing is going on. Yes, 2 increased by 6, so it will be 8. Minus 1 plus 6, it will be 5. So 5 plus 6, it will be 11. So in every term of y coordinate, there is 6 is added, and but in each term of x coordinate, there is 0 is added. So by inspection, means by observation also, you can say this single transformation is equivalent to translation by vector t 0, 6. So this is one of the approach. Means what is one of the approach? If it is asked to find a single transformation, very closely observing A, B, C and its final image, you may explore some rule, and that rule is called the single transformations. Now, our second part of discussion is its graphical approach. Same thing I will try to explain from the graph. From this graph at first. Here, since we are going to talk about two line of reflections, y equals to 1, and let me show y equals to 4, and this both line, you can see y equals to 1 and y equals to 4, both lines are parallel to each other. So they are the line of reflections, and they are parallel to each other. Let me make this line slightly unique. So I want to change the style of this line so that it looks different than others. Yeah, even I like to change the color also, distance color also. Let me choose this green color. Okay. Now you can see here a line of reflections. Here is some problem now. Okay, so you can see this dot line. One is y equals to 1 and y equals to 4, and they are line of reflection. Now I'll choose one of the triangle to do the reflection manually. Yes. Okay, this is a triangle I have chosen, and I don't like to give the name of the site, so let me make it disabled. Okay, now triangle ABC is an object. Now dear students, here also the formation of its images. Let me adjust this graph. Okay, it's okay. Now from this system, by using this GeoGebra apps, I will form the image under this. This is the formation of image. You can see A dash, B dash, C dash. When it is reflection on y equals to 1, same thing we discuss. And the next task is again A dash, B dash, C dash is reflected on the line y equals to 4. And the image is this. This is the image. Let me do some adjustment here, distance. Okay, it's okay. Okay. I will make this image of triangle ABC. That is, first image is A dash, B dash, C dash. Slightly colorful. I like to make it colorful. I like to give this color, okay, this color. Let's give this color, okay. This is the first image, you can see, pink color. And the final image, that I will make it, okay, green. So if this is the questions of combined transformation, and you have to show the object and images, and this is the actual demonstration in graph actually. Okay, this line of axis no need to draw, but you have to plot triangle ABC, and similarly A dash B dash C dash and A double dash B double dash C double dash. So this is a part of problem. Illustration of these two line of reflection and formation of images on the graph is like this. But the last point what we are talking here, two actions we have done. One is first reflection of ABC on the line y equals to 1. Let me do one thing here. C and C dash, they are actually point of invariant because they are coincide with each other. Okay. Now look at here what I am talking here. Now what is the single transformation equivalent to this combined transformations? Instead of doing reflection on y equals to 1 or y equals to 4, how can we get A double dash B double dash C double dash directly from ABC? So what we have done, we have explored from the inspection. If we do translation by the vector 0, 6, then it is possible. So I'll check that from graphically as well. Now for that, let me select this point. One more point, let me select. Okay. Origin. The name of origin normally is O, so let me rename this. Now here I'll choose one vector. Whose value is 0 and 6. 0 is x component, so you can see here in the left side of this screen 0, 6. This 0, 6 is a vector. Now here I'm going to demonstrate the translation activity here. Okay. Now dear students, so what we are talking, let me repeat again. So triangle ABC is reflected on the line y equals to 1 and form A dash B dash C dash. That is the first image colored by pink color. Again A dash B dash C dash again reflected on the line y equals to 4 and form A double dash B double dash C double dash, and that is colored by green color. Now what is the single transformation? Instead of doing these two separately, is there some single transformations? Yes, the single transformation is equivalent to translation by 0, 6. So how it is possible? Translation is a displacement. Like you see here, you can see here. For example, look at here. Initially it is triangle ABC. Now when I do displacement like this, translation, it reaches here. So that's why this process is translation vector. So what is my point? This triangle ABC, when we do translation like this by the vector 0, 6, also form triangle A double dash B double dash C double dash. That's why if the line of reflections are parallel line, then the single transformation is translations, and you have to explore that translation vector by inspection, means by observing very carefully. It is possible to find that translation